Well, in the last video, we had a straight line and we showed you how the x and y axis, we showed you how this straight line was connected to the equation y is equal to mx plus c. Now m was the slope and this was a straight line, so we call this a linear equation. So moving on a little bit from that, let's see if we could do, say, something that didn't look linear, but looked more like a curve that might go like something like that. Well, there's a special name for this shape, and this is called a parabola. It has one turning point, and in this specific example that I'm going to show you, there's the positive y numbers, there's the x axis with the positive x numbers and the minus negative x numbers out to the left. This particular example, this is a parabola, and it's just got one turning point, so it's mapped onto a function that's got an x squared in it. Once you have a turning point, you know there's an x squared in it, so it doesn't follow a straight line. And there's two important points in this graph. There's a couple of important points, but it looks a bit like a smiley face, and a good way to remember that is that a smile is a positive thing and this x squared is positive. Naturally enough, the reason I'm saying that to you is if it was minus x squared, that would naturally give you a frowny face and your graph would have a positive parabola, but it would not be positive, it would be a negative parabola. So we're going to deal with a positive parabola today, and that's a x squared equation. The highest power is x squared. So that's really simple, isn't it? So far so good. So on the graph here, I'm just going to put in two sample points. This point here where it cuts the x-axis, and this other point here where it also cuts the x-axis. These guys are called the roots of the equation that maps out this parabola. So these guys are the roots, and that y-axis here, as you count down from whatever it is up here, maybe 10, 5, 4, 3, 2, 1, down to 0, it's where the curve cuts the x-axis. Those are called the roots. And in this situation, we'll say that this guy might be here. It's not 0, it's not minus 1, it might be minus 2. And this guy here might be out in plus 3 somewhere, so it'll be 2 there. And let's say it's not to scale. So our roots are, the roots of this graph are minus 2. So x is equal to minus 2, and x is also equal to 3. And that all happens at y is equal to 0. So when y is equal to 0, the shape cuts the x-axis, which means it just crosses over the x-axis. And saying y is equal to 0 just means it's the point that it's not a positive value, it's not a negative value, it's just here in the middle. So it crosses over this, when y is equal to 0, so it crosses over the x-axis. Now we've got 2 points, this guy and this guy, and they're part of our parabola. So these roots are important because from them we can work out what the equation of this shape is. And the way we're going to do that is, the first little trick is just taking this guy by itself, x is equal to minus 2. I want that 2 to be this side. So I've got my x staying where it is, and I'm going to add on 2 to that, and I'm going to add on 2 to the far side, to the right hand side of this equals, and that way over there it equals 0. That's what I want. And essentially the 2 has, you can think of the 2 has jumped over the equals if you want, but I've just added on 2 to both sides, and that's negated that 0. That minus 2 has gone to 0 now. So we're happy enough with that. We're going to do the exact same with this. I want this 3 over the far side. So to get rid of that 3, I'm going to take 3 away from that, and it's going to be 0. So I'm going to have to take 3 from this side. It's also going to be 0. Now we've got both our figures on the left hand side of the equals and 0 on the right. That's what I want. taking both of those, we want to work out what our equation is. It's not a linear equation, it's what's called a quadratic equation, and it's got an x squared in it. So to multiply these together, that's how we're going to find our equation. So x plus 2 is no longer a root. Once we do this trick, it becomes what's called a factor. And a factor is, so two factors multiplied by each other give you a product. So these two guys, I'm going to multiply them by each other, and it's going to give us a product. And the product is going to be the equation. It's definitely got a plus x squared in it, but we don't know the rest of the equation just yet. So factors, these are factors, write that down. Factors. And just to stop there and do a little example up here, say we had number 12. Well, the factors of 12 are 3 by 4, and 12 would be the product. So two numbers multiplied by each other would be 12, 8. Two factors of it would be 2 by 4. 8 by 1 is another factor of two factors of 8. 12, you could have 6 by 2 is also two factors of 12. That's fine. These are factors, and this is the product. Okay, so that's a simple example of the same thing we're going to do here. So these two are our factors. We want to multiply them by each other and get the product, and product is what we're interested in, the equation. Change color to another blue here. So following the rules of this, I've got x plus 2 got to multiply by x minus 2. Now we've got more than one term, so this x here, I'm going to take that out and multiply it by the second bracket, x minus 3. Fine. Take the second term, plus 2, multiply it by the entire second bracket. Hopefully that's obvious to people. I'm just multiplying this first term by the whole second bracket, and then this second term by the whole second bracket. And that way we've covered all bases. X by x is going to be x squared. X by minus 3 is minus 3x. Plus 2 by x is plus 2x. And plus 2 by minus 3 gives us minus 6. Okay, that's brilliant. That's great. That's happy days. We've got the highest power we've got is x2, and there's no more of those, x to the power of 2, and there is no more of those, so that by itself is as simple as we can make that guy. Now this is different. We've got an x and an x with no power, so that's the power of 1 really. And we've got minus 3 and plus 2. So we can just add those two together. It's just as simple as say I owed you €3 and I'm paying you back 2. I still owe you €1. And this 6 doesn't have an x beside it at all, so we're just going to leave that as it's 6. We've now got this equation, and it does indeed have an x squared in it. We're happy with that. That means it's a quadratic equation. Now, quadratic is a special type of what's known as a polynomial. Polynomial means there's more than one term. So if you had a x cubed, x to the power 4, x to the power 5, and so on, they're all polynomials. Quadratic is the one that has an x to the power 2 in it. Polynomial. So quadratic is a type of polynomial. All quadratics are polynomials, but not all polynomials are quadratics. And so this is our quadratic equation here, x to the power of 2 minus x minus 6. And that would, so if we put in different x values, we've got x's here, if we put in, say we put in minus 1, minus 2, minus 3, plus 1, plus 2, plus 3, all these different x values, we would get out different y values, and they would, this minus 3, say, would lead me to a different y value. It might be up here. So minus 3 there. If I put that into my equation, it would give me a y answer up here. So therefore we put that point there. And if we were to do all of the x values, we would end up with a shape like this. And say we put in plus 3. Well, the y we already know value. If I put in plus 3, the y is going to be 0. That's why that's what the root is. So 3 is a root. Also minus 2 is a root. If I put in minus 2 into this equation, the y is 0. But should I put in a 4? If I put the 4 into the equation, 4 squared, 16 minus 4 is 12 minus 6 is 6. So the answer to that one would map onto a 6 on the y-axis. And that's where the shape of this graph comes from in the first place. So every x will give us a different y value. So we're going to rewrite this: minus x squared minus x minus 6 is equal to y. And that would be our quadratic equation. That's where it comes from. That's how they relate to the graph. So we've covered roots, factors, and this special type of equation that gives you a curve, and the curve is called the parabola, and the equation itself with the highest power being x squared is called a quadratic.